Welcome to Project Guts on chemical reactions. We're going to start you off with a base model of the reaction of silver nitrate and copper solid. This reaction takes place in solution, and the products of this reaction are the copper nitrate that will be soluble in solution and the solid silver that will deposit. Let's take a look at the interface now. You will see that we have a setup button. This is a run once button, which means that when I click on this button, it will perform a certain number of steps once. In this case, it will clear the terrain and will create water agents. Each water agent represents one water molecule. The water agents are here to remind us that we are in solution, and that is where the reaction is going to take place. Now we also have an add copper strip button. This is a run once button also. It will create 150 copper agents, each representing one copper atom. However, notice that if I click this button again, now we have an additional 150 copper atoms that are created. We cannot see them, but they're on top of the other 150 atoms or agents. So be careful with this button. I'm going to hit the setup again to clear the terrain and add one copper strip which has 150 atoms. Now notice that we have a slider for the silver nitrate, and that goes from 0 to 500. So if I put it at 500 now and I click on the add silver nitrate, then we will have 500 silver nitrates that will be suspended in solution. This is an ionic compound, and so we represent that by the silver nitrate agents that are mixed with the water molecules in solution. Now we have a forever button. The forever button is not a run once button. It's actually a continuous loop button that will execute the steps in the code over and over again until this button is clicked again to stop the model. So here we go. This button is going to represent when the reaction starts, which in real life would be like adding the copper to the silver nitrate solution. Notice right away that the number of copper atoms is going down, the number of silver nitrate is going down, and the number of silver atoms is increasing. The reaction will continue until one of the reactants is completely used up. And in this case, it looks like the copper atoms are going down faster than the silver nitrate, or the 150 we're down to 30. Here we started with 500 and now we're down to 245, 44. So you see that the reaction will continue until one of the reactants is completely used up. Remember, we started with 150 copper agents. How many silver atoms we have now? We have 290 so far. And the number of copper atoms is almost all gone. So, and you see that the red copper agents are now completely gone and almost completely gone. There's like one little one somewhere, and now they're all completely gone and it's all covered by the silver agents. So notice now that the number of copper atoms is 0. The silver nitrate, there's still an extra 200 silver nitrate. We started with 500, so 300 of them reacted and 300 silver atoms were produced. And even though the reaction stopped, the model is still going on until we press the forever button again to turn the model execution off. So let's run this model again. This time we are going to start with 150 copper atoms. However, let's bring the number of silver nitrates down. Let's try to go with 150 again, silver nitrate. If you can't get the 150 exactly, click on the arrow key on your keyboard. So we're going to add 150 silver nitrate and 150 copper atoms. Click the forever button, start the reaction, and let's see what's going to happen. Again, both numbers are going down and the number of silver atoms is going up. Now let's zoom in a little bit. I want to point out something that's taking place on that copper rod or the copper agents. Notice that when the silver nitrate agent first collides with the copper agent turns a gray color. But when another silver nitrate agent collides with this gray copper, the copper atom is now completely gone into solution as copper 2+ ion, which is one of the products of this reaction. For simplification purposes, the copper plus state, the copper plus 1 state, is represented by the gray copper agent and is considered in a transition state. Now, keep looking at the model. You notice that we have a lot more copper atoms this time. The silver nitrate seems to be the one that's going to run out first. We started with 150 silver nitrate and 150 copper atoms, and now the silver nitrate we're down to 38, 37. While we're waiting for this model to finish the reaction, I would like to point out something in the code. In the world, we need to look at how does the world counts the agents. So let's take a look at the data box, for example, of the number of copper atoms that is updated in that data box. Notice that it counts the number of copper agents within 200 steps. Now, why 200 steps? It's because spaceland is made up of 101 steps in each dimension. The x-axis goes from -50 to 50, the y-axis goes from -50 to 50, so you have 101 steps in each direction. So if the world is counting all the copper atoms or all the copper agents in the spaceland, it's safe to count within 200 steps. That really covers all spaceland, even diagonally or across from one end to the other. Actually, even the number 150 would be enough to cover all the steps in spaceland. We'll get back to the code later. Let's go up again to the interface and see where we are with this reaction. Okay, well, it looks like there's still some silver nitrate left, and there's still some copper atoms left, and the reaction is taking place beautifully. It's a good time to start thinking about whether this model is really representing the balanced chemical equation correctly, and the amount of copper that's being used up, and the relationship between that and the number of silver atoms that are produced, and the ratio between the silver nitrate that's being used up and number of silver atoms that are being produced. So this is a preview of the model. Don't forget to use the model observation form as you go through and test this model.